This video is going over the 2-5 check-in. The first question is asking you to rewrite this by completing the square. So when you're completing the square, you need to first take care of the coefficient that's in the front there. So I'm going to factor out a -2, and I'm going to get x squared minus 10x minus 10. And then I'm going to take the part that's in the parentheses, and I'm going to complete the square with that part. I'm going to ignore the -2 for now. So I'm going to make a little box. I'm going to put x squared here. I'm going to take the -10x and split that up into 2. So I would have x minus 5 and x minus 5. -5 times -5 gives me 25. I have 25, but what I need is -10. So in order to get a -10, I'm going to need to subtract 35. So that's what's going on inside the parentheses, but I factored out this -2. And so that -2 is still there. That -2 needs to be multiplied by everything that's inside the parentheses. So I'm going to multiply it by the box, which is my perfect square, and I'm going to multiply it by that other, my second number. And so this equation in the end is going to look like this. Y equals -2 times the perfect square that's in the box. So that's x minus 5 squared. And then I'm going to multiply -2 times -35, which is positive 70. And so this is now that same equation, but written in vertex form. The second question is telling us it's a polynomial with degree 4, and they're giving us 3 zeros here. It says find the missing zero. So we have 2 real zeros, 2 and -2. We have this one imaginary zero, and we know that those always come in a conjugate pair. So the other one is going to be 2 minus 3i. And we're going to write it in factored form and then in standard form. So factored form is relatively easy. We're going to just take our factors and our zeros and change them into factors. So we'll have y equals x minus 2, x plus 2, x minus 2 plus 3i. So if I subtract 2, and then I also need to subtract the 3i, and then I'm going to do x minus, and I'm going to subtract both of those. So I'm going to have x minus 2. If I subtract -3i, I'm going to get positive 3i. So this is what the equation looks like in factored form. Now we need to take it and change it into standard form. So changing into standard form is kind of tricky. We have a lot of multiplying that we need to do. So we have 4 factors to multiply together. And I'm going to try and just multiply them in pairs first. So I'm going to start by multiplying these first 2. They're pretty easy to multiply. It's just because the middle 2 terms are going to cancel out. So I'm going to get x squared minus 4. This one here is not as easy to multiply. So I'm going to use a little area box in order to do that. So I'm going to create a 3 by 3 area box, and I'm going to put this one down the side, and I'm going to put this one across the top. And then I'm going to multiply. X times x is x squared. X times -2 is -2x. X times -3i is -3xi. -2 times x is -2x. -2 times -2 is positive 4. You want to be really careful with your positive and negative signs. -2 times -3i is 6i. And then 3i times x is going to give me 3xi. 3i times -2 is -6i. 3i times -3i is -9i squared. When you do this, your your imaginary parts should always cancel out. So those 2 are going to cancel out. These 2 are going to cancel out. If they don't cancel out, that means that you have done something wrong. If you end up, you're trying to get a polynomial in standard form that are going to have real coefficients, you want all the imaginary parts to disappear. And so what you're going to end up with here is x squared. And then you've got negative 2x minus 2x is going to be negative 4x. And then you have a 4, and then you have this negative 9i squared. So negative 9i squared, remember the I squared is negative 1. So this is really equivalent to positive 9. And so I'm going to add positive 9 plus 4, and that's going to be 13. So this part here multiplies to be x squared minus 4x plus 13. These first two factors multiply to be x minus 4. And now you can multiply those out. You could do it with a box, or you could just use the distributive property. I'm going to do it with a box because I think it's easier to keep all of the terms kind of straight when I'm doing that. So I need just a 2 by 3. I'm going to put x squared minus 4 down the side, and I'm going to put x squared minus 4x plus 13 along the top. X squared times x squared is x to the 4th. X squared times negative 4 is negative 4x squared. Negative 4 times x squared is negative 4x cubed. Negative 4x times negative 4 is positive 16x. 13 times x squared is going to be 13x squared. 13 times negative 4 is negative 52. So the only like terms that I have in this case here is the negative 4x squared and 13x squared. Nothing else is a like term. So I can now write this as a polynomial. I'm going to put my x to the 4th first, minus negative 4x cubed. I'm going to combine those two like terms. I'm going to get plus 9x squared, and then plus 16x minus 52. So this is what the polynomial would look like in standard form. This next one, I'm going to multiply these two complex numbers together. I could use the distributive property of FOIL, or I could just use a little box. I'm going to do it using the box. And I'm going to get 5 times 5 is 25. This is going to give me negative 40i. This is going to give me positive 40i. And this is going to give me negative 64i squared. So again, these imaginary parts cancel out. This I squared is equivalent to negative 1. So this is going to really be equivalent to positive 64. So I really just got 25 plus 64, which is equal to 89. The next question is asking us to find the roots using the quadratic formula, and then to rewrite the quadratic equation in factored form. So we want to first use the quadratic formulas. Remember, this is A, this is B, and this is C. And so I'm going to do negative B, which is negative 4, plus or minus B squared is 4 squared minus 4 times A, which is 1, times C, which is 7, all divided by 2 times 1. And so I can simplify this because 4 squared is 16, and 4 times 1 times 7 is 28. So 16 minus 28 is negative 12 divided by 2. And then I can simplify this because I have negative 4 plus or minus. The negative can come out, so I'm going to have an I. And then the square root of 12, I could simplify that because 12 is 4 times 3. So I could take the square root of 4 out, which is 2. And I'm going to leave that as 2 root 3i divided by 2. And then I can simplify that some more. Since I have these two terms and they're added or subtracted, and then I have this long fraction bar divided by 2, it means that the first term is divided by 2 and the second term is divided by 2. And so x is going to equal negative 4 divided by 2 is negative 2, plus or minus 2 root 3i divided by 2. Those two 2's can cancel out, and I'm going to get root 3i. So those are my zeros, or my roots. But the question also asked you to write it in factored form. So to write my factors, I'm going to do x minus my 0 and x minus the other 0. And I'm using parentheses as I substitute in there because I want to make sure that I remember to distribute those negatives. And so my final factors are going to be x plus 2 minus root 3i and x plus 2 plus root 3i. And so this would be the factored form. Actually, we would want to write it as f of x equals the factored form.